Hello everybody, Root Beer here with question number 3 on the Hypatia contest from 2007. I want to thank you all first for joining me as we look at this question here. Consider the quadratic function f of x equals x squared minus 4x minus 21. Okay. Determine all values of x for which f of x equals 0. Okay, so we'll set up the equation, and they've sort of given us a little helping hand here, but we probably didn't need that. So we want x squared minus 4x minus 21 equals 0. We want to solve this. Well, this is a quadratic equation. So if we wanted to, we could just use the quadratic formula. Negative b plus or minus the square root of b squared, that'll be 16, minus 4 times a times c, and c is negative 21. All over 2 times the leading coefficient a, so 2. Okay, so this is grade 10 stuff, so you should be familiar with that. Of course, you could also do this by trying to factor it, and some of you who've had a lot of experience with factoring will be able to do this pretty quickly in your head, so that's another way to do it. But let's just finish off our quadratic formula. So really, I'm showing you 2 ways to do this one. The negative signs will cancel out. It'll become plus 84 all over 2. Well, that's x is 4 plus or minus. This is 100. Square root of 100 is 10. So it'll either be 14 over 2 or 4 minus 10, so negative 6 over 2, 7 or negative 3, and that's what we would read off from here as well. If we've got these 2 things and they multiply to be 0, one of them's got to be 0. So either x minus 7 is equal to 0, or x plus 3 is equal to 0. And in either case, we get x is 7 and x is negative 3. So either way you do it, don't show both of them. You might end up confusing someone who's marking it. But either way, factor it in your head. That will mostly work. But the thing that always works is the quadratic formula. Okay? But, sometimes it can get a little messy because you got to put all these coefficients in here. And sometimes it's just easier to think it through. But when in doubt, quadratic formula, because you know it will work. Okay? So either way, we get our answers of 7 or negative 3. The roots are 7 and negative 3. So roots or zeros of the polynomial, whatever you want to call them. Okay, so now we got B part here. If s and t are real numbers, such that s squared minus 4s minus 21 is equal to t squared, so f of s is equal to f of t, is what they're saying here. Determine the possible values of s plus t. Explain how you obtained your answer. Okay. This is actually an interesting one. So I'm going to show you 2 ways to do it, just like I did with A part. So in A part, we just did factoring or quadratic formula. For this one, I think there's an algebraic way to do this, and I think there's a nice geometric way to do it. Of course, we can manipulate the equation that they've got set up, f of s is equal to f of t. We'll do that just fine, but remember, f of x is a quadratic, and quadratics are parabolas. They represent parabolas when you graph them. So I think this is basically sort of a level set curve on the parabola, which is a very advanced term for something I'm about to show you. So I'll show you 2 ways. You'd only need to do one of them. So x squared minus 4x plus 20 or minus 21 equals 0. I'm going to complete the square. So we're going to get x squared minus 4x. What do I need to make this something squared? I need a plus 4 here. So minus 4 minus 21. Got to make sure these cancel out. And then we don't need the 0. We need equals y. because we're going to graph this. So then this is x minus 2 squared minus 25. And now I've got the parabola in vertex form. And this makes it very nice and easy to graph. So we'll drop a grid here. All right, now it's minus 25, so it's the base is somewhere way down here. It's an upward-facing parabola because it's not negative something squared. It's actually positive something squared. And it's 2, negative 25, which we'll, I guess, place here. Okay, and from there, our parabola opens up. Okay. So, things to note. The parabola is symmetric about this x equals 2 line. And we could even put the negative 3, 0, and 7, 0 that we've seen. Now, because the parabola is symmetric, these guys are going to be the same distance away from 2. They're both 5 away from 2. But, and so this is what I mean by a level set curve. If you just draw sort of a horizontal line saying y equals blah, you'll get some points here. And, this is over t, and this is over s. So s and t are the solutions to a particular fixed vertical amount here. Anyway, if f of s is equal to f of t, then they sort of lie on the same line like this. Okay, but because the parabola is symmetric, it's going to be the same distance on either side to either point. Okay, so the nice thing here is this dividing line 2 is the average between s and t. So might say something like by the symmetry of the parabola, you see s and t are evenly spaced from 2. And another way of saying they're evenly spaced from 2 is to say, or rather, 2 is the midpoint of them, or 2 is midway between them. But how do we calculate midpoints? S plus t over 2 is equal to 2. No matter what s and t, as long as they have the same y-coordinate, the symmetry of the parabola takes over, and we get this. And so from there, s plus t is 2 times 2, which is 4. And we were asked, what determine the possible values for s plus t? Well, there you go. These are the only possible values. They did want s and t distinct, right? Yeah, they're different real numbers. The only other possibility would be if you just took your level set curve right here at negative 25, and then you'd only have one s, and like s and t would be equal, so this wouldn't exactly... Oh, no, s plus t would still be 4 there. Okay. So yeah, this works because they're on either side of the parabola, so the 2 is midway between them. Okay, so that's a nice geometric, it's picturey, I like it. It's a little vague because it says, by the symmetry of the parabola, and this is not a property that we're just going to go out and prove here. You probably could if you wanted to, but I'd say it suffices. It would get you all the marks for B. So I'm going to show you an algebraic way to do it, which is a little more exact, but, it's not as fancy as this picture. It's some people would call it a little more dry. So another way to do this one, they've given us the setup. S squared, it's minus 4s. Minus 21 is t squared minus 4t minus 21. I'll bring it all over onto one side. S squared minus t squared minus 4 s minus t. And then the 21s will cancel out. Okay. So we've got this. Now, what we can do is s squared minus t squared. This is difference of squares. So it can be very quickly. If you haven't seen that before, it's a fantastic thing to have memorized. Something squared minus something squared can immediately be factored in this way. Okay. But now we've got 2s of s minus t's. Now, like I said before, if we've got a product here and it's equal to 0, one of these has to be equal to 0. But s and t are different. They told us that. Okay, so that tells us that s minus t is not the one that's equal to 0. So s plus t minus 4 is equal to 0. Or rather, just rearranging this one, s plus t is equal to 4. Okay, we did it 2 different ways. This one very algebraic. We don't get a nice picture-y sense. This one has a nice picture, very elegant looking. But you say, well, the symmetry of the parabola, this is not something that is very rigorously used here. But either way, s plus t is 4, and that's the only way it's going to work. Okay. And now we've got C part here. If a and b are different positive integers, such that a squared minus 4a minus 21 minus b squared minus 4b minus 21 is equal to 4, determine all possible values of a and b. Explain how you obtained your answer. Interesting. So, what are we to do here? When I'm reading this, I'm not immediately seeing a picture in my head. So, when I saw the s squared, that it was f of s is equal to f of t, immediately in my head it popped in, oh, this is sort of, they're both on the same y aligned through the, with a fixed y. But with this one, there's not a geometric intuition that's springing to mind. There might be one. You would need, so different positive integers. So you need sort of positive integers. And so if a is here, then b is somewhere over here, but it's 4 spaces above. And that's not the most obvious thing to be using. So since I don't have a geometric intuition here, I think I'm going to fall back on the algebra. It's more exact, and I don't need to have a picture in my head to do these questions. Sometimes it helps, and it makes it nice and elegant for the marking. So I think I'm going to rearrange and do the same sort of thing. We'll have a squared minus a b squared kicking around. So a squared minus 4a minus 21 minus b squared plus 4b plus 21 is equal to 4. I expanded the minus sign out here. Minus, plus, plus. Okay. So these guys cancel out, and I am left with a squared minus b squared minus 4a negative b is equal to 4. And we're going to factor out the a minus b again. A plus b minus 4 is equal to 4. All right. So there's no zeros here, so there's not going to be sort of specific answers. But we reread the question. They do say different positive integers. So since a and b are positive integers, a minus b is an integer. Okay, that can be guaranteed. I can't say it's positive, but I can say and a plus b is a positive integer. And then a plus b minus 4, I can't say that that's a positive integer too, because maybe a plus b is 3 and then minus 4 is negative 1. But yeah, so we've got integer times integer. Well, and the product being an integer, the 4 can only be broken down in certain ways as a product of two integers. So 4 is equal to 4 times 1, 2 times 2. Now I don't know the order here, so we're also going to have 1 times 4. And then negative versions of each of these. And I can probably rule out the negative version some way. But let's get our whole list first. So these are the only ways I can write 4 as a product of integers. We can say that. Only ways to factor 4 over the integers. Okay. So that means, a minus b will have to be 2 and a plus b minus 4 will have to be 2, or that sort of thing. Or a minus b is negative 1 and a plus b minus 4 is negative 1. So, just trying to see, is there some way I can shorten this? Well, if I add these, the a's become 2a, and the b's cancel out, minus 4, and this is 2 times a minus 2. So this is even. And if I have a sum of two things, I can't have them, I can't have one be even and one be odd. So sum of the factors, and I don't mean sum as in a collection, I mean sum as in add them all up. The sum of the factors must be even. So that just really gives us 4 is equal to 2 times 2, or negative 2 times negative 2. Because if I use the 4 and the 1, they'd add up to be 5, which is not an even number. Okay. So this is nice, and it reduces things down, because a plus b minus 4 and a minus b have to be the same amount. So rather than even assigning them equal to 2 or negative 2, maybe I can get away with this. This has to be true. And so let's rearrange this. The b's will come over onto the other side. So 4, the a's will cancel. 4 is 2b. Therefore, b is going to have to be 2. And that's all I can say. Can't do anything about a right now. So either a minus b equals 2, in which case a is equal to 4, or a minus b is negative 2, in which case a is equal to 0, and that works as well. So the only, and the, I was about to say the only positive integer solutions, but this one has a not positive integer. I almost forgot about that. Would have gotten it wrong. So a equals 4, b equals 2. Is the only solution among the positive integers. So just drawing a parabola again, I think I can believe that. So 2 down here, and then we go over by 2, and you'll have gone up by 4. And the parabola gets steeper and steeper, so that's not really going to happen again amongst integers, let's say. And the only other way to do it would be to have your a over here and your b over here and a difference of 4. But that's because the parabola that we had was so close to, 2 was the axis, so you're really not going to get a whole lot of, this possibility is going to be in the negative numbers when that happens. So yeah. That does it for question number 3. Just wanted to sort of check my answer mentally, and it all worked out. So that's 3C, and that finishes up the whole question. So thank you guys, as always, for watching, and I will see you for question number 4 as we finish off the 2007 Hypatia in the next video.